right, so this is our project. So first we're starting up with some assumptions. First, the network is unreliable and it has a packet loss probability. Each end node is only attached to one router. All the links have the same characteristics, as in all the hop costs are 1, and the maximum transmission unit is 1500 bytes. It has a small amount, like a small maximum number of nodes. The network address is statically assigned, and the packets do not get corrupted during transmission.
So our protocol aims to provide a service to send packets to K out of N nodes. For our control plane, our protocol will find a route with the minimal hops by finding a common path between the destinations, and that way it'll find the shortest path to the final destination. And our ARQ scheme, we will be using go back N to ensure efficiency and reliability.
So here we chose very simple packet formats for our control packets and our data packets. So our control packet would be used to send first to create the routing tables and send updates like hello messages, acknowledgements, and updates in case of a node failure. It contains the ID, source address, destination address. Our data packet, however, is a little bit contains the destinations, the data, source address, and the ID, which will be explained in the next slide.
So in control packets, our ID will identify the types of control packet. It will have a hello to check for new nodes, an acknowledgement and response, and updates to neighbors about node failures. It will also have the source address as well as the destination address. In our data packet, the ID identifies the number of recipients, and it'll have the 3 destination fields. That is the data to be transmitted.
So here we're talking about a little bit, we're talking a little bit more detail about the routing algorithm. So we're using a link state algorithm. It sends out hello messages periodically to discover new nodes, or if a node was disconnected. It locally computes the shortest path at the nodes and stores them at each node. Update messages again are sent out in case of any node failure or any change in the network. Hello and acknowledgement and update messages are sent between the routers again. And this is just a simple diagram to show that we're sending out messages between the routers. The routing table will contain the destination, the sequence number, the hop count between the destinations, and the next hop.
So each of the routers will check the shortest path based on the hops to the destinations, and it will save the routes on the routing table. And then if a common path is found between the destinations, then that path will be taken. The destination router will make copies of the packet and compute the path to the rest of the destination. And each router will forward the packet with the path with the least amount of hops. So we'll show that in the following examples.
So for the first example, we again state that each router would have all the possible paths to all the other nodes and routers and destinations. So if a common path is found to reach more than one destination, that path will be taken first. So for example, we find that the path to D1 from node 1 are 1, 2, 3, 1, 4, 5, 3, or 1, 6, 7, 5, 3. All these nodes have one, and then the nodes from node 1 to D3 are the rest, which is 1, 2, 3, 5, and 7, 1, 4, 5, and 7, and 1, 6, and 7. Here we can see that there are 3 common paths, all with 4 hops each. The 1, 2, 3, the 1, 4, 5, and the 1, 6, 7. So if we choose the path 1, 2, 3 as a common path between all of the 3 destinations, we would then go 1, 2, 3, split the packet and copy the packet 2 times, and then take the rest of the destinations to D2 via 1, 2, 3, 5, and then D3 via 1, 2, 3, 5, and 7. So again, the packets get split at router 3 since that's the end of the common path, and then the rest of the other 2 packets go on their way from 5 and 7 or 3 and 5.
Similar to the previous example, each router will have all the possible paths to all the routers. And so we find that the shortest path to D1 would be 1, 2, 4, and 1, 3, 4. And the shortest route to destination through 2 and 3 is 1, 3, 5, and 6. Here we find that the paths 1 and 3 are amongst both of them. And so the path will bifurcate at router 3. And so the path taken then would be 1, 3, 4 to get to destination 1, and then 1, 3, 5, 6 to get to destination 2 and 3, which results in 8 hops rather than 10 hops, which is the shorter.
And as a summary, again, we specify that we're trying to create a K out of N multicast network. We're using LSP and go back N schemes. We calculate the minimum hop routes and check for common routes as well. The overhead to create the routing tables would be a lot, but it's very scalable for larger networks. And again, hello messages and update messages can be bandwidth intensive, but they're good for creating good routing tables.